Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons. We're on number 34, and I think we're at the beginnings of trying to make a alarm system with our Raspberry Pis using LCD and a keypad and some other sensors to do that. Um, this week we were just mainly working on the uh, input and output, so we don't have to use a TV monitor. So we got the LCD and a keypad for input and output of our data and stuff, or whatever else we need to put in and read. So I I'm going to take a F on following directions on this class because Paul is going to go with using threads to make this um, work with uh, blocking code that he used for the input. And that's one way around getting away from blocking code is um, uh, using threads so that the threads don't block each other. But my position is, why use blocking code at all? You can get away with it most times. So I'm going to get an F, but I did get gist of the assignment done where he wanted us to be able to uh, enter a code and then press a key and also be able to change our code. So I decided to take out all the letter keys A, B, C, and D, and I figured, looking forward to this alarm system, that A would be for armed and D would be for disarmed. And if we want to change our password, I figured C would be a good one for that. And then we also need a way to get back to a known state. I guess you would call it home state. So I figured the B would be be what your best thing to do to get back to the a known state, home state. So our passcode and things we got can be 0 through 9 plus the star or the pound, either one, or valid keys. But the letter keys are going to be uh, indicate that we've entered our code in some state. So that's how I decided to do it. And uh, also, like I said, Paul turned his um, keyboard into a class and everything. And I actually put it in a separate file like he did, but I didn't turn it into a class. I was we'll get to the code. Let's talk about the code. So we'll go to the code here. So if you look at, I learned by looking at what others have done. So if you look at the LCD code that we had access to on that we're using, it's actually just a code, but it doesn't have any classes. A folder, I mean, a file that doesn't have any classes in it. But we can still import it. It's just got a bunch of methods in it, and I figured, well, that worked for them, so I figured I was going to do the same thing. So what I've done is set up an alarm system functions list. So I do most of my work in here, and my main code is just trying to figure out what the keypad is showing us. So we're putting all of our arrays or lists of lists in here, and we're also defining a keypad start. That puts our setup for a keypad in there, and LCD start. That's the LCD stuff. So we didn't have to clutter our main code with that. Um, this get key and this check entry were things that I was doing with my non-blocking code last week or week before, or whenever I was showing that off. And I just kept that basically the same. You notice I got an underscore in front of the get key. And it seems like Python users use that underscore to indicate a method that is not generally used from the user screen. I mean, it's just an indication you could use it, but if you see the check entry calls the get k function or method. So I just kind of just put that in there to indicate that that's the case. So again, this is non-blocking. It comes in here, it runs this code, runs through it one time, checks to see if there's any letters pressed and letters pressed or numbers pressed. If numbers pressed, it just adds it to our string for our for our entry string. And also if it's a letter, then it this done flag is set to true if it's a letter, and then it returns whether it's has a letter code. It just returns true if it has a letter as a thing. Also, the LCD, since I did the setup over here, I figured just as easy to send make a method over here where you're writing to it. And I actually did find something. I think that some people have noticed that if you have a long string in a line of on your LCD on like the first line or whatever, that if you put a short string after it, that a lot of times it doesn't cover up the last letters. So I found this format method, the string format method, where you can tell it that it's going to take up whatever your message is. It's going to take up 16 characters, and the message will be left justified if it's a string. If the message was a number, it would be right justified. But we're using strings, so even though it's numbers mostly, it's still a string. So they're going to be left justified, but they're going to cover up whatever is in there. So that's cool thing that you can do this .16 and it's going to do that. This formatting here makes it show up. So I did that for both the first line. So I got display line 1 and display line 2. So we can set each one of them. I figured basically what I'm doing for this part of it is you have a message on the top line and you're displaying your code on the second line. And then the same way the cleanup and everything, since our GPIO library has been called in this folder or this file, and also time so far in the LCD clear is also there. So I just, after our exception, keyboard exception, I just come over here and just run this function one time and do it all over here, and then it goes back to the code and closes everything down. So that's a couple cool things. Another difference between what I do and Paul has done is he's doing like blind entry of your numbers, and I guess that's okay, but I don't have enough confidence in this keypad that it not going to not accept the key, or even though I'm got it so it shouldn't double accept a key, but if you let off of it a little bit and then push it back in, then it could bounce a key. So I just want to have a record of what I'm entering as I'm entering it, so we'll see that as it's working. So like I said, this is 50 some lines of code, and these are where all my functions are. And then this is the main part of the program over here. It's also 59 lines of code. But the only thing we're importing on this one, because we imported everything in the function file, is we just import the function file. It's called alarm system function. and I just imported just to shorten it to as ASF. That way, every time I call something, a function out of it, I only have to put the ASF in front of it. So, and another thing that I started out with having this is just a list, and you use that list and you can put different things in it by index. But I said, yeah, maybe with as difficult as this is, maybe I need to use what they call a Python dictionary. So a dictionary is a key and data pairs. So this state is just start, and I'm not even using that in this program, but I figured at some point we're going to want to know the state of our system or whatever. And then we have several other last key that I was trying to work with. The entry, that's what we're putting as we're punching in numbers in here. That's what's going to show up in there. And then our save password is 1234. So we've got that going on. And then when we enter one of our A, B, C, or D, then we're going to also be able to record which one we pressed and put it here. That way it's automatically passed between the functions. We also have a system status. So right now I have it just as armed and disarmed. I just figured that just going to show armed and disarmed. And so I also need a flag to let us know that we were in the middle of a password change. So as Paul said, you want to be able to, you have to enter the old password, and then I press a C, and then it's going to ask you for the new passcode, and then you can then you type that in, and then you type the C again, and it accepts it. So while you're entering that new passcode, you have to make sure that you know that that's what state you're in, because if you're in the middle of entering a passcode and you say, well, I forgot what I was doing, and you come back and you say, well, I want to make sure it's armed, and you just hit your passcode and then A, then it's thinking that you're updating your passcode and you're not. So there's just a flag to show you that you're in the middle of it. Again, the home button, the B button, will take you back to a steady state. So it's going to clear the change F flag, and also just clear the entry thing. So it's going to put your entry back to nothing, zero, just an empty string. And it's also going to display your status, whether it's armed or disarmed. So let's get it down into the code. And I knew this from doing Arduino things with keypads or different ways of doing stuff, that your user interface is usually the hardest part. Doing the stuff where you're reading your sensors and stuff like that tends to be easy. But dummy proofing a user interface is kind of hard. And I wrote this and changed it 2 or 3 times, because every time, like I say, I'd go to use the keypad and say, well, what if a user did this instead of what they were supposed to? And, it would break the system. So I'm hoping, like I say, I got, quite a few lines of code just to keep track of what keys are pressed and what we're doing when when we, whether it's an A, B, C, or D thing. So we have a lot of ifs here. If it's A, if it's B, C, and so this is C if the first time through, because changed F is false. But then once you press it, it changes it to true. So it only come through, it'll do this if it's true. So this is where we started. It checks to make sure the old passcode was right, and make sure you put a new passcode in. or sets the flag that the next time you're looking to put a new passcode in. And then the next time you hit the C, it's going to know that you entered a new passcode. So you're saving that from your entry into your passcode. There's a lot going on in this code, and probably am not explaining it very well. But like I said, this is all non-blocking, so you could come right down here and just start reading sensors, because it's going to read them just as fast as it can. I mean, you could still, this code is taking less than a millisecond probably to complete, so you can do whatever you need to down here still. So this is all non-blocking. It's just a bunch of if statements. And I'm looking forward to see what Paul does with the threading and stuff. But I just thought that for me, this was a better way to go. Threading also has a problem of when you got a thread and you want to return information from it, you got to make sure that, there's different ways of doing it, but one way is to use like a list or something. And you got to make sure that your main thread and your other thread aren't looking at the list at the same time, because you can get data crash errors from, they're both looking at it, and they can be problematic if you don't be careful with that. But like I say, I'm interested to see how Paul handles getting data from the keypad thread back to the main thread. So anyhow, so that's enough talking. Let's just show it in works, hopefully. So let's see what happens. So you can just barely see it down there. This is not the best camera. I got this camera, but you can see system running down here and the keypads up there. So if you noticed, I started off up here with the default password is 1234. So if we just want to see what our system, go to the home, so we hit the B key, and it just goes back to what the home thing with the system status. So we start out it with it disabled, so it says system disabled. So if we want to, or disarmed, I guess, not disabled, disarmed. So if we want to arm our system, we're going to type in our passcode and then hit A for arm. So we're going to say 1, 2, 3, 4, 4. See how I thought I pressed it, but I didn't. 4, and then A, and now it says the system's armed. And you do the same thing if you want to disarm it. 1, 2, 3, now 4. Now, if I accidentally typed a different number or something like that, and you say, well, what do I do now? Well, the B takes you to the home screen, so it just kind of takes you back to a known state. So we can do this again. 1, 2, 3, 4, and we want to disarm it with a D, and now it's disarmed. All right, so now we can show that how to change the password. So we have to put in our old password first. 1, 2, 3, 3, 4. And then we're going to press the C, and it says enter new pass. So I'm going to put 1, 1, 1, 1, 1. Whoops, 1. See how my keypad just doesn't press hard all the time. And then I'm going to press the C button again, and it says good new password. So now, if I want to check it, so I go B, this just goes back to the home screen. So it says the system's disarmed. So if we want to arm it, I have to put in my new password, which is 1, 1, 1, 1, and then the A, and now it's armed. So if I try to use the 1, 2, 3, 4 to disarm it, it's going to say bad password. And 1, 2, 3, 4, and then I can just B to go back to the home screen. 1, 1, 1, 1, one. See how the button presses don't always show up. I don't know whether it's my keypad's a little flaky or what, but my code should be working for it. It should only record one, and it should record it when it sees it. Because, you know, like I say, it's less than a millisecond. I know I holding it down for more than a millisecond. So, and then if you want to disarm it, you just hit disarm. So that's my code. Like I say, I've already got over 100 lines of code, but to be honest, I think I've always found that the user interface UIs for these things take much more coding than the actual thing. So if we go to read a PIR sensor or send our alarm off or something like that, then that's you know, I think that's going to be, you know, probably not add that many more lines of code to it. But anyhow, that's the way I did it. I get an A for getting the process working, and an F for following direction on this one. So anyhow, thanks, Paul, for all you do, and look forward to seeing what your solution is. Have a great day.